Welcome you all. Welcome to Google Cloud Next Day 3. Good morning. First off, just to start, I want you all to appreciate one thing, right? This is day 3 of a Vegas tech conference, and you're still here on a Friday, bright and early in the morning. I want you all to first give yourselves a round of applause, please. Cool. Just to get the conversation started now, I assume all of you have heard of or use daily Apache Spark in some way, shape, or form. How often have you all experienced operational toil, steep learning curves? Has that been the conversation for any of you? A quick show of hands. Cool. With that being said, have you wondered or has anyone asked you, hey, this is the age of agentic AI. These problems should not exist anymore, right? Agentic AI should solve this for you. Any of those hands? Quick show of hands. Cool. You've come to the right session. We'll see how we can solve that for you today. Cool. So I'm Bhooshan Mogal. I am a senior product manager trying to simplify Apache Spark at Google Cloud. I have with me my colleague, Newton, who heads engineering for Apache Spark, and Cesar, who's our partner at Mogal. Let's get right into it. So a little bit about today. We'll go over the background of why you should care about Apache Spark and how we at Google are working to make it simpler day by day, week by week for you. Quickly step into a product demo, hopefully spend most time there. And then I'll hand it off to Newton to peel the onion and discuss some of the magic that made that demo work. And then we'll hear about a real-world use case for Apache Spark at Mogal. Let's get right into it. You've seen this slide, I'm sure, about 10 times each over the past 3 days, right? But this is no longer just a buzzword, right? Agentic AI is truly here. It has changed the way I work. I'm sure it has impacted your professional lives in many ways as well. But this is creating new demands of your data platforms as well. Right? So at a high level in the world of data science, we're observing a seismic shift. The shift from traditional data science, which involved statistical modeling, predictive machine learning, and that's slowly evolving into generative AI, LLMs, agentic action, and so on. So if you step a few feet below, what this essentially boils down to is 3 things. The first, the kinds of data that you have access to has changed. Your models were expecting structured data in a database, warehouse, and so on. We've since then stepped into the world of multi-modality, multi-format, multi-shape, multi-location, all kinds of data needing access to your, being available to your models, right? It has secondly changed the patterns, which is from analyzing historical data and running predictions on them, we're now moving into providing intelligent business context to foundation models and letting them take action on your behalf with your supervision, right? And then lastly, in terms of examples, from the classical fraud detection, pattern recognition, we are evolving into content generation, code generation, tooling that does jobs on behalf of you, takes action, right? So truly what is happening is you no longer can rely upon your data platform to merely be intelligent. It needs to be a system that takes action on your behalf. Right? Again, it boils down to 4 things, which is unlimited access to data to begin with, regardless of location, type, shape, format, modality. You want intelligent context, so a model cannot work in your environment if it only is trained on the world's logic, right? It has to have deep, deep context of your business, your customers, your use cases, things like that. And then as agents are doing work, they're doing work at a scale that is unprecedented. They're generating even more data as well. You need really scalable, flexible platforms that can handle this data and then continue improving your systems. And then in order to get to magic moments faster, you need agentic AI to help you throughout your journey from discovering a use case to actually building out a solution to solve that problem, and then putting it in continuous execution in a production environment, right? And by the way, that we don't see as a destination. We see that as a continuous loop, right? So a model deployed in production running continuously is not an end state, right? It needs to continuously learn. Every day's experience needs to be better than the previous day. So there's that continuous optimization loop as well. And while all of this is happening, you want to take price, performance, security, governance just for granted, right? It just comes, you don't talk about it, you get best in class. Stepping into how this manifests into open source analytics, Apache Spark is the world's most popular distributed data analytics platform out there. It's baked for several different years, over a decade now, and has been in production at the world's largest enterprises. People are getting value out of ETL, stream data processing, rapidly evolving into a machine learning platform for interactive analytics as well. But the problem is that this thing can be incredibly complex if you start off just by downloading open source bits. That's where we come in, right? So at Google Cloud, we believe there is a fundamentally different way to run Apache Spark. We believe we can make it easier, we can make it smarter, we can make it faster. We want to eliminate any and all operational toil, any and all learning curves, make sure that practitioners, regardless of their skill sets, can actually start getting value out of Apache Spark. We want to infuse Gemini into every single layer of the stack in order to make smart decisions on your behalf and make Apache Spark that much smarter and simpler. And then faster, you've all heard about Lightning Engine. We're continually evolving and pushing the boundaries of price performance. That's how we think Apache Spark should be run. Right? How many of you all have used Apache Spark on Google Cloud and heard the word Dataproc? Fantastic. So just a quick announcement. Dataproc is now called Google Cloud Managed Service for Apache Spark. It's a rename. We're not taking away any functionality, but it's a fundamental shift in how we think about the product. Right? We used to have two products before. One was a clusters product, the other was a serverless product. We're converting them into deployment models, which means you come in with your Apache Spark code, you build it using your favorite IDE, and then once you're comfortable, you decide whether you want a cluster or you want to just run the job and not worry about infrastructure. Both the form factors give you enterprise-grade security governance. Both are completely open and flexible in terms of their APIs and wire protocols. Both are AI-ready. Both support GPUs. Both support our agentic development kits. And both support our price performance kit in the Lightning Engine. Right? The only difference being in one, you manage the infrastructure, which is the clusters form factor. In the other, we take away that management responsibility from you as well. So you get control with clusters, and you get ease of use, or more ease of use with serverless. Right? And we're not on this journey alone. You have the world's largest enterprises running mission-critical workloads on Google Cloud, have helped us evolve the product over the last 10 or so years now, and only getting better day by day, quarter by quarter. Right? For the rest of this session, we'll step into the world of serverless Apache Spark a little bit, just bringing down that message of easier, smarter, and faster in a serverless land here. I won't go into every single piece of the slide. I'll let you take photos. But essentially, the message here is with serverless, we are trying to expose Apache Spark to a wide array of data practitioners, regardless of their skill sets, taking away the steep learning curves, taking away the operational toil, and giving you access to Apache Spark so that you can quickly put your business logic into action. We'll see some of these capabilities that we've talked about throughout the session, so I won't go into a lot of them yet. And again, we're seeing massive validation of the fact that serverless is a real use case. Customer usage is doubling year over year, and this trend is continuing for the past few years now. We have some real-world examples. We'll have Cesar talk about their experience with Spark as well today. Cool. Enough talking. Let's step right into a demo. So for this demo, I want you all to imagine that we are an e-commerce retailer. We have a website. Customers buy products from us. We have our product inventory data stored in a data warehouse. Could be in our operational store as well, but for now it's in BigQuery. I also used generative AI and Apache Spark to actually generate some simulated customer reviews for our products. That's stored in a lakehouse on GCS in Apache Iceberg format, and it's registered with our Spark environment through the lakehouse runtime catalog. What we're observing is some of our products have a high chance of getting returned. That's impacting our margins, that's impacting our bottom line, and we need to do something about it to take predictive action. What if we could prevent a shipment label from being generated instead of generating it, shipping the product, and only to realize that the product has to be returned, right? Let's see how we can go about that really quickly and easily. So here is roughly the demo architecture. We have our data in a lakehouse across BigQuery and GCS, fronted by the lakehouse runtime catalog. We have the processing layer happening in Apache Spark using Spark 4.0 and Spark Connect. We are using an XGBoost on Spark model, as well as Spark ML to do some predictions on this. And then we'll generate a risk score. That model will register into a model registry, set up an endpoint, and do an online serving as well. So let's get right into it. So what you can see over here, I'll pause here just a little bit. So while we have that e-commerce website where products are being sold, there is an internal dashboard over here that's showing you that order pipeline on your left. And then in the middle of the screen, there is what I call as an interception protocol. That's where the analysis is happening, scoring is happening, a request is going for every order, and then the model is telling us whether to go ahead with the shipment or to back off and halt, right? And there is so if you see now, as an order comes in, it goes through that interception protocol, and then that decides over there if it should be shipped. You can see 6 products being intercepted over there, and then there is an MCP tool at the bottom that tells you, that takes that action on your behalf. Now let's step into how we actually build this. This is a Collab Enterprise notebook in this case. We have the Spark session loaded up. We're telling Gemini the use case, right? And we're expecting Gemini to come up with a plan. This is underneath the covers using the data science agent, but all the skills that we've built for this agent are actually open source and are part of the Google Cloud Data Agent Kit. So you can use this in your own development environment as well, right? With your own agentic harness. So let's wait for Gemini to come up with a plan. As you can see, it's going through the traditional understanding the data, extracting features, loading up, building the model, training the model, running some evals, comparing results, and then downloading the model, which can then be uploaded into the agent platform for online serving. We won't wait for it to, I don't want you all to sit here, wait for the wheel to spin, right? So I had done this before as well. Let's step right into that notebook that Gemini had generated. As you can see, it describes each task that is generating, the reasoning behind the task. So it's going through data loading here, preparation, trying to understand the data, the schema, ultimately figuring out some features that it wants to extract out of the data. And then it'll go into a training phase, first with Spark ML, and do some random forest classification. while it picks up. And as this is happening, right in the notebook, you can see monitoring information, those clicks, those links that you see for Spark query over there. You click them, you get insights right into the notebook about how your job is running, the execution graph, whether anything needs to be optimized. If any failures occur, how do you react on those failures? So it went over, Spark ML in this case, discovered some probability of the product being returned, doing the same thing with XGBoost, and then it'll select XGBoost as our preferred model plotted on a graph, and essentially give us the model file that we can then connect to Gemini agent platform and set up an online inference server. That was essentially the demo for today. I hope you all enjoyed it. Our goal here is to make this as easy and seamless as possible. While this was all easy to see, I'd love to call upon stage Newton now to go over, peel the onion, and figure out and tell you the features that actually made this possible. Take it over, Newton.
Hello, everyone. Thanks, Bhooshan. By the way, the peeled onion was his idea. We saw the demo. I'm going to spend some time. Oh, by the way, let me introduce myself. My name is Newton. I lead the Spark teams in Google's analytics org. I'll be talking a little bit about Lightning Engine. So we built the Lightning Engine. I lead that team. All right. So going to the next slide. OK, something is not working. OK, now it works. All right. So let me start with the same slide that Bhooshan showed, right? Here we have a nice, crisp architecture diagram. On the left-hand side, we see the data warehouse. In the middle, we see the compute we are using, the kind of models we are using. On the right-hand side, we see the inferencing and the prediction stuff. This is a lot crisp and nice to see, but we didn't start from here, right? Let me ask a simple question. How many of you here have some kind of experience with data science? You built a model. OK, quite a few. All right, so you all know the process. It doesn't start like this. It's not as crisp as this. So we start with exploration. We go figure out what tables we have, what are our data sources, how are they linked, do we have the permission, is this data trustworthy, and all those stuff, right? So the first part is the exploration part. And once you explore, you go to the next phase where we focus on the development. So here's where Bhooshan mentioned about the the data kit, the data agent kit. So you can use your own IDEs. You use different types of models. You can use different flavors of these, is UI-based or CLI-based. And once you build, you go through the development and testing phase. And then we go to the CI/CD, where we deploy these models to production, where it runs. The next stage would be the run stage, where we use some kind of optimized compute engines. It could be Spark, it could be BigQuery, it could be any of the open source engines over there. And finally, we go over the monitoring and troubleshooting. If something goes wrong in the production, how do we troubleshoot that? So these 5 phases, right? We went through these 5 phases. And when Bhooshan said, hey, peel the onion, it was that. How do we unravel these multiple layers of technology and processes that we use to build the model? So the circle there, discover, I just mentioned. How do we explore the data? The develop part, where we build the actual models and the tooling required, includes the data preparation, feature engineering, and all those things required for data science. The deploy side, where we actually do the CI/CD, some kind of scheduled deployment and run mechanism. The actual run mechanism, where we use the different kind of engines, and the troubleshooting. So I'll spend some time in each of these phases and walk you all through the tooling and everything we have used. And in the process, introduce the new innovations that we have done in each of these phases. All right? The first one is the discovery phase. So many of you would have heard about knowledge catalog. There are a lot of photos, so I'll step aside for a moment. All right. So what is knowledge catalog? Knowledge catalog is our exploration and governance tool. Right? It does three basic things. First is aggregation. It collects data from multiple data sources. Now, this could be your warehouses, this could be your lake houses, it could be your partner ecosystem. It aggregates data from these multiple ecosystems. And secondly, it enriches the data. It adds a lot of metadata. It uses its own agents and models to annotate the data. It adds descriptions, find the connections, form the graph. Right? It adds semantics and meaning to the data sources. The third thing is your actual query layer. It has a powerful search engine that can give you as a user or an agent very quick responses. All right. So we use knowledge catalog to figure out where the data is. Is it in our iceberg lakehouse? Is it in our BQ warehouse or any other mechanisms? You can use Spanner or any other databases for that matter. There's a second type of catalog. While knowledge catalog knowledge gives you the business intelligence, there is the second level of catalog called the runtime catalog, the Lakehouse runtime catalog, which gives you more of technical metadata. Now, these are low-level data corresponding to your tables, your schemas, your access controls, where your data is stored, and all those things. So these two catalogs together form the knowledge basis for us. All right? And now both these are linked together, and you can access most of the IRC data. When I say IRC, it's Iceberg Risk Catalog data through knowledge catalog itself. So that is the exploration phase. Now the develop phase. So Bhooshan showed the agent work, the screenshots over there. Yeah. So nowadays, I think almost everyone, each of us use agentic models to build our systems. We most probably prompt it, and everything gets built. So the Cloud Data Agent Kit is mainly for that. You can use your IDEs, and it just works. You install the Cloud Data Agent Kit, and you get that entire agentic experience at your own IDEs. We have Visual Studio Code. Bhooshan showed the Collab Enterprise, and we have a lot of these support for IDEs coming very soon. The second good thing about the Data Agent Kit is it's end-to-end. You can do everything from your exploration, building the tool, debugging it, deploying it, everything from the same IDE itself. Right? And you have the different flavors. You can use the UI or CLI based on your convenience. The same agent can also be used to deploy. This is the third phase. Just give a prompt, and it builds the entire pipeline. Apologies, this is too small. I couldn't fit the entire thing in the screen. On the left-hand side, you see the YAML. On the right-hand side, you see the graph. Right? This is all generated with just a simple prompt. And the good thing is it works seamlessly with your Git commits, mergers, like a traditional CI/CD pipeline. You do a merge or a Git commit, it triggers the pipeline, and you can very easily schedule it to run at predetermined time or based on events. And if something goes wrong, the agent is always there with the full context, so it can very easily debug what's going wrong and tell you. Right? This is all within the same ecosystem. The next one is the run phase. So this was the engine I was talking about, and I'm usually stoked when I talk about Lightning Engine because that was the big announcement from our team. So Lightning Engine is an advanced engine that runs within Spark. So it's 100% open source compatible, and it runs almost 4.9, not almost, it runs 4.9x faster than OSS. And if you had a few more days, we could have made it around figure 5. All right, so Lightning Engine is a multi-layer optimization. It's not like, hey, one engine plugs in and it works. It works at multiple layers. The first layer is optimizer, the Spark optimizer. We have changed a lot of algorithms there to make it very efficient. The second layer is the execution layer. We use a vector-based execution. And then there are two more layers. There's all these connectors, We have the GCS connector, we have the BQ connector, which are optimized for these engines, these vector engines. And right at the middle, we have a decision-making layer, which intelligently decides, hey, which part of the subtree should I push down for native execution, and what happens in the Spark world. Right? So if you have not tried this, you should definitely try. It's a very simple thing. You go to your screen or a flag, and it's just a little check mark there, and you'll get Lightning Engine enabled. No changes to code, it just works. And Bhooshan's demo used Lightning Engine to do the merges from the Iceberg and the BQ table. There's a second option. We have native support for NVIDIA GPUs. To make things easy, we have shipped images with GPUs pre-pack, right? All the NVIDIA drivers, your CUDA drivers, your QDNN drivers, your NCCL binaries, and the common machine learning libraries like PyTorch, XGBoost, and stuff like that, right? So it makes it very easy. You don't have to manually install any of these things. Just deploy the image or select the image, it gets deployed, and you just go run your models on top of it. And one announcement I want to make, so we have made the dynamic work scheduler GA. This drastically helps you with GPU obtainability, right? It helps you with the task queue up and scheduling, and we have seen really good GPU access with DWS. We have a little quote from one of our esteemed customers, Snap, who has been using this for quite some time. And they've observed up to 75% in reduction in the startup time for any of these AML images. All right, the next concept I want to introduce that we used is auto-tuning. Now, all of us know what auto-tuning is. And in the managed Spark, the serverless version of managed Spark, we have auto-tuning in preview, which looks at your historical runs and then optimizes your jobs accordingly. Now, what's the difference between auto-tuning and Lightning Engine? Now, imagine you have written a Spark job. OK, I know I already saw a lot of hands here who have written data science workloads. How many of you have tuned a Spark job? Raise of hands? Few. And how do you know you've reached your, you reached the max efficiency possible? I don't think any of us can answer that, right? So imagine there is a threshold that we can reach by tuning all these things. Now, your auto-tuning can take your, let's say, not the most efficient configuration to that level, right? By looking at the history, by understanding the pattern of the job, so we're looking at the partitions of data and whatnot. So this is auto-tuning. Now, Lightning Engine can take your existing Spark limit and boost that itself much higher. So the difference is that, one can take you to the theoretical limit of what Spark can do. The other can give you a step increment in Spark's performance itself, right? So you can use both these in collaboration. One is to make sure your jobs are doing better. The other one is to boost the performance. This is the last part in the run thing. We've done quite some investments in the lakehouse. So we are moving towards the open lakehouse infra. You must have heard a lot of talks around this in the last 2 days. So bucketing into 3 groups. One, performance. I spoke about Lightning Engine. Now that, along with Iceberg and Delta, we have invested in both these lakehouse formats. You get much faster merges. You get optimized vacuum, faster compaction. Right? I'm not going to go through the details. The second one is interoperability. With IRC, it becomes multi-engine compatible just like that, right? And we take care of the Iceberg lifecycle, which means all your garbage collection and manifest maintenance is taken care behind the scene. And we made it very easy to connect. From Spark, you just give the catalog name, and it just connects, right? So all these things are to make it easier for everyone. The last part is the governance and data access. I spoke about knowledge engine. That is the basis for most of our governance stuff. And with IRC being federated right now, you can access any of your catalog across clouds from here, right? And security is the last thing I wanted to cover. You can apply consistent security across your SQL and Spark workloads with RBAC and credential vending today. All right, the last one, the debugging part. So when things are running fine on your production, it's all good. But when things go wrong, you definitely need that support. The good thing is with the agentic data kit, or the data agentic kit, it can do it. Since it has the context, it can take care of these things mostly well for you. But together with this, we have something called the Gemini Cloud Assist. Now, these models are trained with the last 5 or 6 years of all our support cases and all the exceptions we have seen from the engineering side and whatnot. So it has a very high chance of giving you very accurate results on what could have gone wrong, beyond the development thing, on the production side of things, on the data skewness and stuff like that. And on the Spark monitoring, we have something called Serverless Spark UI, which is an on-demand PHS. It has all the data ready for you real time. All right, I'm going to rush through this. We saw all these 5 steps: discover, develop, deploy, run, troubleshoot, and all the innovations we have done in these areas. All right, with that, I think I'm done with my section. I'm going to invite Cesar here from Moloko to share their experience on Serverless Spark. Welcome, Cesar.
Thank you so much.
Thank you.
And good morning, everyone. I appreciate everyone being here. Yeah, let's give a big round of applause. You guys must be really passionate about Spark if you're here, so it's good to see you guys. I'm from Moloko, principal ML engineer. So I work with a lot of teams that take our data from our live system through our data pipelines and into our model training. So I did modeling at Google for a long time. And yeah, to do modeling, you need to have really good pipelines. And I'm representing a lot of work from Hayden Lee on my team, and on a sister team, Hanung. And Hanung is in the audience here today. So if you have really detailed questions, we can go to him after the session. So first, what is Moloko? We see ourselves as an engine to drive the internet economy, because if you have a product, you need to monetize it, and we help do that with the state-of-the-art ad systems. Today, I'm going to mostly represent the first part of our company, Moloko Ads. So we work very closely with both sides of the company, but just from the use case point of view, where we drive ads on mobile products and performance connected televisions. Okay, so what does that mean? What do? We do programmatic advertising, which means it's performance-based advertising. When the way it works is there's a public exchange. A bid request is sent to multiple DSPs, which we're one of those. From there, our systems decide how much we're willing to bid on a certain piece of traffic or our inventory. And we do this by matching our internal demand onto these platforms. So we have to do this. On average, we usually respond within 300 milliseconds. Yeah, and this, you can see the loop. And yeah, so we run an internal auction. There's an auction on the exchange. And ultimately, there's a winner, either us or someone else. And this is just a loop of the process. And this generates a lot of data for ML. This is the bid request we got. If there were impressions or impressions that other advertisers have placed, some clicks, and conversions. And conversions are the final result of, hey, this person has installed an app or has done another activity that we find valuable or the advertiser finds valuable. Let's move on. So this generates about up to 10 million inferences per second. This obviously fluctuates through the market on a daily basis on a certain day. And it funnels down to about 3 billion training events per day that we get into our system. So a large volume, maybe you guys have more volume or less, but this gives you the scale of our product and what we do. So I go straight to the result to keep you guys interested. Yeah, moving to serverless Spark from our previous pipelines for certain pipelines have yielded really, really good results. On average, for the pipelines that we converted, 65% less time, which obviously is also at reduced cost given how much time we have reduced. Let me check my notes. Yeah. And then, this is something that varied a lot depending on the pipeline, on the configuration and what the pipeline was doing. So sometimes you see up to 40 to 80% reductions depending on the pipeline. And this is not all the pipelines at Moloco. We start trying to expand, and we're getting really good results, and we love it. And we're trying to see where else we would go with this. So what do these jobs do? You can see, yeah, we connected to BigQuery and cloud storage, but this is funneling all the data from the live systems down through several steps. For my team, we ultimately lead to the training data, but in between, there's several offshoots that other data science teams use for analyzing our performance and then producing data for customers as well, where they can summarize. So how possibly could we get such a big benefit? A lot of it is a serverless Spark, especially. We've noticed is really great at really large objects. So when we have 500 columns or more, and this really, it was very optimal for this use case, where in our previous pipelines were not. And then also, this gave us a big opportunity, having some of these pipelines had been around for years, to look through our pipelines and really analyze them. So this is maybe not related to Spark itself, but is a good way, the way Spark forces you to think about things in a certain way, to reevaluate how we were doing things. And this added to that multiplier that we got from moving on to Spark. And another aspect of it is that we realized that Spark, for our use cases, were really valuable for very large joins. And we're talking more than 3, more than 5, very large joins, because all the data I mentioned earlier has to eventually get joined together. They come through separate data streams and in large volume. And we have to do this for every single bid request. So these large joins actually became very, very efficient on Spark. And yeah, we matched this with other features. There were other changes we were making. Iceberg was great for also doing this and moving to Parquet and other various file formats through this process. And some of these pipelines are around 12 terabytes of data processed at a time, to give you kind of the scale in terms of size itself. So one of the great things in being in an agentic world is that we had very ambitious plans. We have tons of pipelines. But how do you go from your previous system to the current system, which is now going to serverless Spark? Yeah, we took advantage of a lot of AI coding tools. No surprise to anyone here. But we were surprised at the level that we were able to accelerate through this as developers get better at our internal tools and our internal workflows get better. You can see, like, this is just trying to give you a reflection of how that growth came. So this is really to give you guys, say, hey, if you have, hey, this might move into Spark, or something like this is too risky or it might take too much time, this is something you really should think again. With the right tools and the maybe really strong engineers, you can do this very quickly and get results very quickly. And obviously, at our scale, this is very valuable for us to do. And then, yeah, we're hoping also to connect our internal agents into the serverless Spark universe inside Google to also connect those agents together. And then why do we use serverless Spark? Well, first, we wanted to migrate quickly. We wanted to yield the benefits of moving to Spark as quickly as possible, minimizing our internal cost and engineering costs. And we've tried both ways, both serverless and non-serverless, and realized serverless is the great path for this. And we weren't using serverless. We were seeing issues like, out-of-memory issues. And then moving to serverless Spark, this just became a lot easier. And luckily, we also got a lot of support from the Google team to get there quickly. And actually, the UI is also great. It really helped us kind of like develop a lot faster. Hopefully, this gives you a good idea of what we do and the benefits we got. I'm happy to go in more detail after the talk. But yeah, thank you for having me.